Physics 2054, Fall 2011, Exam 1, Questions 2 and 3. Questions 2 and 3 are the same as Question 1, so I'm going to generalize it for an arbitrary charge at each point, and then I'm going to plug numbers in and show that it works. Okay, so we start out with an equilateral triangle with points A, B, and C. Because it's an equilateral triangle, the angle is 60 degrees, and the distance between any 2 points is some distance I'm going to call r. But it's the same for AB and AC. The question is asking for the force in the y direction divided by the force in the x direction, magnitudes. So to solve this, we have to first find, let's say, Fy. So F in the y direction is equal to the component from the A and C particles plus the component between A and B. Now, particles A and C both lie in the x direction. So any force between them will be in the x direction. So that's 0. We can just ignore it. Now, the force in the y direction between A and B is equal to the total magnitude between the two times the sine of the angle, 60 degrees, that it makes with the x-axis there. So sine 60. So the force between A and B is equal to K times Q1 times Q2, since those are the charges of A and B, divided by the distance, r squared, times sine of 60, which is √3/2. Perfect. Now let's find the x component of force. This one won't be quite as easy because one of the terms is not 0. But still, it's the component between A and C plus the component between A and B. So let's find Fx in AC. Since both lie in the x direction, all of the force is in the x direction. So the x component of the force between A and C is just equal to the force between A and C, which is equal to K Q1, which is charge of A, times Q3, charge of C, over the distance r squared. And the force between A and B in the x component is equal to, similar to the y component, it's force between A and B times, this time, the cosine of 60. Great. So from before, we know that Fa and B is equal to K Q1 Q2 over r squared. And from trigonometry, we can figure out that the cosine of 60 is 1/2. Great. So now the total force in the x direction is equal to, I'm going to pull out like terms. So it's K Q1 over r squared times Q3, right, from that one, plus 1/2 Q2. Great. Now let's take the ratio of Fy to Fx. Fy is equal to this, which is K Q1 Q2 over r squared times √3/2. And Fx is K Q1 over r squared times Q3 plus 1/2 Q2. And we can cancel out like terms. The k's go, the q's go, or q1 at least, and the over r squared. So that is equal to q2 root 3 over 2 over q3 plus 1/2 q2. Great, now let's plug this in. So for problem 2, q1 is equal to, let's see, for problem 2, q1 is 3, q1 is 1, q2 is 3, and q3 is 2. Okay, plug this in, you get 3 root 3 over 2 divided by 2 plus 3/2. Okay, so that is equal to 3 root 3 over 7, which you can plug that into a calculator and find it is equal to 0.74. Awesome. Now question 3. Q1 equals 1, Q2 equals 2, Q3 equals 1 again. Okay, plug it into the equation. You get root 3 over 1 plus 1 equals root 3 over 2. Yay! And that is how you solve an equilateral point charge force problem, such as questions 1, 2, and 3.